Hey guys, in this video we're going to take a look at just some basics about functions. First of all, before we can define functions, we need to talk about what a relation is, okay? Because the definition of a function depends on that definition. A relation is just simply a set of ordered pairs. They don't necessarily have to be numerical ordered pairs, although ours will be, okay? And remember here what an ordered pair actually is. That's an x and a y coordinate for us, okay? The variables can be different, and in certain classes or in certain problems they may be something besides x and y, but for us that's what we're going to see. The first element there is called the domain element, and then your second element is called the range. So if you talk in terms of the domain or range of a particular function, the domain of that function is the set of all x's that work for that particular equation, and the range is the set of all y's that work for that particular equation. Okay? Now, the definition of the function: a relation that has no repeated first elements. Okay? So the first element for us here is the x. So our functions will have no repeated x coordinates. Okay? That's the basics of that. Now, let's take a look at a couple of examples and see how to tell whether a relation is a function or not. We're going to look at three different forms of a relation, okay? The first is just simply sets of ordered pairs. Now, these are the easiest ones to type, okay, to tell if they're functions or not. If we take a look at this one, remember what the definition that I just told you is. A function will not have repeated x's. So look at each one of the x values. If any of those repeat, this cannot be a function. All right, so what we see is in the first and second points, we have the exact same x coordinate. So this one is not a function. All right, now let's take a look at the second set right here. Again, check the x's. This time they're all different. I've got a 1, a 5, and a 2. Okay, so this one is okay. This one's a function. Now remember that these relations are just made up of the points that you see. They don't contain any other points. They're just simply a list of points. Okay, that is one way to get a relation. They don't always have to be equations. And then the last one, let's take a look at it. Now what I want you to notice here, we do have no repeated x's. All the x's are different, but we do have a repeated y. Okay, and the definition doesn't say anything about y's repeating, so that has no bearing on whether or not it's a function. Okay, there are special types of functions called one-to-one functions where you don't have repeated x's or y's. We're not going to go into those, but I just want to let you know, okay, there is something special about the ones that don't repeat anything. Okay, so that's how we work with ordered pair sets. Okay, now let's take a look at graphs. There's something called the vertical line test for graphs, and that test says that a graph represents a function if no vertical line drawn across the graph crosses the graph in more than one point. Okay, so you could draw a million vertical lines all the way across the graph, but none of them would cross the graph. No one would cross the graph more than one time. Okay, so let's take a look at that applied to a couple of different graphs right here. If I were to draw a little line, see if I can get this one going here. Whoop, missed the graph there. Sorry about that. Didn't mean to do that. Still missing the graph. This is kind of funny how this thing does lines. There we go. There's this one right there. And you can see, let me clean up and get rid of these other two, that if I drew any other graphs, there would be several lines here that would actually cross it more than one time, okay? And let me show you where this one's crossing it. It's crossing it right here, and then again right up here at the top. So that's more than once, one vertical line, more than one time. This is not a function. Okay, that's a circle graph there. And if we take a look at this one, we can do the same thing with it. I think I'll draw them by hand rather than trying to do that little line tool, since it's not working out too good. There's one vertical line. Here's another one. Here's another one. Here's another one. Now I know these edges, well, that one's not too vertical, is it? Sorry about that. I know these edges are not great. You're going up at a very steep angle towards the end of this graph, and so it almost looks like you do go vertical at the end, but you don't. Okay, still, every single vertical line that we draw across this graph is only going to cross it one time each. Okay, so this one is a function by the vertical line test. All right, so if you can kind of visualize what the graph looks like, you can tell sometimes whether something's a function or not by the graph. Okay, just be sure that you can look at a graph and tell that. You can either physically draw lines like I did, or you can shift a pen or a pencil across the graph, just drag it across, or you can just think about it. Okay, just think to yourself, could I draw, is there anywhere on this graph that I could draw a vertical line and it hit it more than one point? All right, and the last ones we're going to look at are relations that are in equation form. To test an equation to see if it represents a function, solve for y. Okay, then see if plugging in one single value for x would give you more than one y value. All right, a couple of things to think about before we look at these two. Anytime y is raised to an even power, or y is inside, scoot over a little bit, absolute value. With either one of those conditions, you don't have a function. Okay, if y is squared or raised to the fourth power, you're not going to have a function. If y is inside absolute value, you are not going to have a function. Okay, so just kind of think about that as we're looking at these three that we have right here. In the first one, I've got y is equal to x squared, so that one's already solved for y. So what we're thinking about here is if I plugged a single value in for x, is there any way I could get more than one answer for y out? Well, you can try a couple of values, like maybe if I plug in a 1, then y is going to be equal to 1 squared, that's 1. Okay, that's one single value. There's no way to get a second different value out of that. If I were to plug in 9, y would be equal to 81. Again, one single value, no way to get anything else out of it. Okay, so that's a function. Polynomial equations where you have x as your independent value, they are all functions. Okay, linear equations are functions. Let's look at our next one here. Now this one's got that y squared like I was talking about right here. Y is raised to an even power. That's going to be a problem, okay? And let me show you why. First of all, let me see if I can move this down a little bit so we've got some more room. If I solve this for y squared is equal to 4 minus x squared. And then if I do the square root property, okay, taking the square root of both sides of this equation, here's what I get. I get y is equal to plus or minus, remember, square root of 4 minus x squared. Okay, it's the plus or minus that makes this statement, if y is raised to an even power, you don't have a function. That's what makes that true, because no matter what I plug in, unless it happens to make this 0, okay, if this is 0, then you're sign neutral, so you don't get two answers. But if it's anything else, if the x is 0, then you're going to have plus or minus the square root of 4, which is plus or minus 2, which is two different values, okay? So you wind up getting two values for y when you plug one value in for x. So that one is not a function. Now this last one down here is a little different, okay? There is no y in that one, all right? It's just x is equal to 7. This is a vertical line, and we'll learn more about we'll talk a little bit more about these, I guess, in the next section, 2.3. But what happens with a vertical line is every single point on a vertical line has the exact same x value. That's what this means. X is always 7, no matter what y is. And so it completely violates the definition of a function, okay? You could almost call it an anti-function. It's so not a function, okay? So this one is not a function. So if you see a vertical line, which is always written x equals constant, then that's going to not be a function, okay? That will not be a function at all.